net EMF. The current I is given by net EMF by total resistance. Sorry, net EMF is 12. The voltage drop across the diode. Voltage drop across the diode is this forward bias voltage. The potential barrier voltage is 0.6, so minus 0.6. So by total resistance 0.3 into 10 raised to 3. ABCD, which you can cause the LED to glow. The LED glow only when it is forward bias. Forward bias means this is 1 and this terminal is 0. Then the LED will glow. PN junction diode D1 and D2 are connected as shown. A and B are input signal and C the output. The ground circuit will be a function of, it is given that. Now you can see this is the standard figure that is taught for the gate you know AND gate. Materialization, electronic materialization of AND gate. So AND gate. There is no more much Now come to the questions from semiconductor physics. PN junction diode D1 and D2 are connected as shown. A and B are input signal and C the output. The ground circuit will be a function of, it is given that. Now you can see this is the standard figure that is taught for the gate you know AND gate. Materialization, electronic materialization of AND gate. So AND gate. There is no more much explanation. Yes, because the standard figure to demonstrate the materialization of AND gate using semiconductor diodes. Okay, and therefore is AND gate. Now, assuming the forward bias condition, there is a voltage drop of 0.7 volt across the silicon diode. The current through diode D1, the circuit is in millimeter. Now, assume the diode or given circuit are identical. You see in this figure, here the diode, silicon diode, forward bias. This one is also forward bias. This one is reverse bias. This one is reverse bias, and that won't conduct. So conduction takes place through D1 and D3, and D2 won't conduct because it is a reverse bias. Then, assuming they have no resistance, the main current through the circuit, main current through the circuit I. The main current through the circuit I is equal to net EMF of 12 volt by total resistance here is equal to 0.53 kilo into 10 raised to 3. So on calculation is equal to 4 into 10 raised to minus 2. Whereas the ampere is equal to 4 into 40 milliampere. This is the main current. The main current now conducts through two identical resistors, and therefore by Kirchhoff's law, the current will be equally divided. The current will be equally divided through both of them. And therefore, you can see answer is correct. One thing, oh, sorry, I'm sorry. Here is the voltage drop 0.7 volt across silicon diode. And therefore, I'm wrong. You can mark like this again. Net EMF, the current I is given by net EMF by total resistance. I'm sorry, Net EMF is 12. The voltage drop across the diode. Voltage drop across the diode is this forward bias voltage. The potential barrier voltage is equal to 0.7. So minus 0.7, sorry. By total resistance, 0.3 into 10 raised to 3. This one calculation is equal to 11.3 by 0.3 into 10 raised to 3. This, it is not a barrier voltage is required, and the net EMF is given by 12 minus. And this on calculation, the value is equal to 18.8 into 2 is equal to 6, 7. This value on calculation is equal to 37.6 milliampere. Now you know this main current distributed equally. The current through each branch is 37.6 by 2 milliampere. The calculation is 18.8. So the option is equal to 1. Now, next question. You are given a digital circuit. Rather than discussing the Boolean and applying the Morgan theorem, better we give the inputs. What are the inputs? 0, 0, 1, 0, 0, 1, and 1, 1. And see the output. Then, whichever table that agree with that is our option. That's okay. Our option checking. That's what we are doing. Give the input and see the outputs. And this is not doing. If you verify, you can say that this truth table will be true for this circuit. 0, 0 is 0, 0, 1 is 0, 1, 0 is equal to 1, 1, 1 is equal to 0. That is the result that you are going to obtain, and therefore the correct option is equal to 2. Voltage regulated circuit. A Zener diode having breakdown voltage of 10 volt and a maximum power dissipation of 0.4 watt is operated at 15 volt. The approximate value of protective resistance. You can see this is our circuit and this is our protective resistance and this is the diode. And breakdown voltage is given to you. Breakdown voltage, that means the voltage across this is equal to 10 volt. And maximum, next one, operating voltage is equal to 15 volt. This is 15 volt. Next thing that is given, we are asked to find what is the value of protective resistance, this one. Yes. That we have to find what is the value of RS. The power is given to you. Power is equal to 0.4. The problem, it is given power is equal to 0.4. At once you can calculate power is equal to P into I. And therefore you can calculate the value of I. I is equal to P by V. P by V on calculation. P by V on calculation, 0.4 by 10. 0.4 by 10 is equal to 0.04 ampere. This is the main current. Next, here 15 is the input voltage and output voltage is 10. Therefore, the potential drop across this one by Kirchhoff law is equal to 5 volt. And the current that you got is equal to 0.04. Then what is the potential drop? Cross required is equal to 5 volt. Then what is the resistance? Again, by Ohm's law, 0.04 into RS is equal to 5. Therefore, RS is equal to 5 by 0.04. That value on calculation is equal to 125. The value is equal to 125 ohm. Okay. Again, repetition question is there. Now, verify the possible input 0, 0, 1, 0, 0, 1, and 1, 1, and see the output. Whichever truth table agree with this one, that is our answer. This is not doing, the option is equal to 3. Next. The following diagram, there are diodes, voltage regulators, and our diode are rated at 5 volt, and the desired current is current in the load is equal to 5 milliampere. The unregulated voltage source can supply up to 25 volt. Consider the Zener diode can withstand 4 times the load current. The value of resistor RS. Similar problem that we did. Light modification. Okay. Now the Zener voltage is given. That is output voltage 5 volt. This is 5 volt. And Zener diode rated 5 volt and the desired current in the load is 5 milliampere. So current through load IL is 5 milliampere. Next thing in the problem is that the Zener can withstand 4 times the load current. So IZ maximum is equal to 5 into 4 is equal to 20 milliampere. It can withstand 5 times. Therefore, 5 into 4, 20 milliampere. That is our IZ value. Next thing. Load, the voltage across the load is equal to 5 volt. The current through the load is equal to 5. And that by Ohm's law, P is equal to 5 is equal to I into 5 milliampere into load resistance RL. From this load resistance RL is equal to 5 by 5 into 10 raised to minus 3 is equal to 1000 ohm. The load resistance is 1000 ohm. Here, again by certain Kirchhoff law, the maximum input voltage is equal to 25 volt, 25. Drop across the or output is equal to 5 volt. Therefore, by Kirchhoff law, the excess that is going to drop across R, voltage drop across RS is equal to 25 minus 5 is equal to 20 volt. What is the main current? Main current is equal to current through the load 5 into 10 raised to minus 3 plus current through the Zener is equal to IL plus IZ is equal to 20 into 10 raised to minus 3 equal to 25 into 10 raised to minus 3 ampere. That's the main current. Now, then by Ohm's law, voltage drop across the limiting resistor is 20 volt and the current through that is equal to 25 into 10 raised to minus 3. Therefore, what is the value of RS? RS is equal to voltage drop across that 20 by current through that 25 into 10 raised to minus 3. That on calculation, the value is found to be 800 ohm. So this is 800 ohm. Okay. Again, diagram is given and what is the truth table? Again, no, not truth table. It is said that the correct truth table for which given the input data for the following logic gate is. Now you can see this as we did earlier. Now give different values for A, B, and C and D. And each truth table is verified. And get the truth table which agree with this one. By trial and error, you verify A, B, C, D values, and out of this, which is found to be agree with the result. And on calculation, you can see that the option 2 agree the results. Okay. In which our trial and error give the different possible input and see the output. Next. Find the correct relation between A, B, C. ABCD, which can cause the LED to glow. The LED glow only when it is forward bias. Forward bias means this is 1 and this terminal is 0. That's okay. Then the LED will glow. This is 1 and this is 0. Now out of the given options, A, B and C, D, which one will satisfy this one? You can see that if these are 1 and 1, here it is 0, 0. 0, 0 on NANDing is equal to 1. So here is 1. Here 0, 0 is then OR gate, it is 0. Sorry, 0, 1. It is 0, 1. If it is 0, 1, then NOR gate and therefore this is 0. Therefore 1, 0 that is satisfies this equation. And therefore option is equal to. Now that finishes our questions. And thank you for watching this video. Once again, thank you.